Welcome to the YC1000 Microinverter installation training. This is the second in a series of online training modules for the APsystems product line of microinverters and accessories and supporting software applications. The target audience for this video training session is solar array installation technicians who may or may not have experience in installing solar microinverters and need to familiarize themselves with the potentially unique aspects of the APsystems YC1000 installation. This training module is accompanied by a short test that can be taken at the end of the module. A certificate of completion of this module is automatically available once the test is successfully completed. But before we get started on the actual training, let's take a few seconds to talk about getting yourself registered as an installer with APsystems. To become a registered, certified APsystems installer requires that you successfully complete at least one hardware installation course, an ECU training module, and the EMA training. You won't be able to set up your customers with online monitoring without being a registered APsystems installer, so it is critical that you get this done before completing an APsystems microinverter installation. Now, on to the training. There are three basic components that make up the APsystems microinverter system: the inverter, in this case the YC1000, the Zigbee-based Energy Communication Unit, or ECU, and the Energy Monitoring and Analysis Website, or EMA. The inverter's role in the array is to convert the DC power that is generated by the solar panels into AC power, which can be utilized by the power grid. The YC1000 is a grid-tied microinverter. The APsystems YC1000 functions as four inverters built into a single case, yet combines the signal into a single MPPT and has the following characteristics. It is a true three-phase inverter that is available in two models based on your specific grid requirements: 277 480 volt and 208 volts. Unlike the APsystems YC500, the YC1000 is a single MPPT unit. An important note here: the YC1000 cannot be used in a delta or high leg system. All three phases need to be balanced for the YC1000 inverters to function properly. While the YC1000 has the capacity of up to 4 modules, it can be configured with less should the need arise based on racking, module layout, and panel wattage sizing. It is best suited for PV modules in the 180 to 310 watt range, but can handle panels in the 360 to 370 watt range. But you'll need to reduce the number of panels per inverter if you utilize these higher wattage panels. For example, an ideal panel size for a 4-panel per inverter design is 280 watts, with a 360 to 370 watt panel design, requiring a step down to 3 panels per inverter. The total rated continuous output power of the YC1000 is 900 watts AC. The maximum number of units per 277 480 volt 15 amp 3-pole breaker is 11, or a maximum total of 44 PV modules, and the maximum number of units per a 208 volt 15 amp 3-pole breaker is 4, or a maximum total of 16 PV modules. The maximum number of YC1000 inverters per circuit is based on the amperage produced by each of the units. For example, in the case of the 277 480 volt units, each inverter is spec'd at 1.08 amps per phase. Multiplying the 1.08 amps times 11 equals 11.88 amps, and multiplying that result by the code-mandated 1.25 equals 14.85 amps per phase, which is under the 15 amp circuit sizing. Using the same approach, the 208 volt inverters are spec'd at 2.5 amps per phase. Multiplying the 2.5 amps times 4 equals 10 amps, and then multiplying that result by the code-mandated 1.25 equals 12.5 amps per phase, which again is under the 15 amp circuit sizing. The YC1000 uses the Zigbee protocol to communicate with the Energy Communication Unit, or ECU, and the ECU collects and stores the performance data from each of the microinverters and sends it to the APsystems database via the site's internet router, so that the array can be monitored via the internet. The ECU, while optional, is an essential component of the remote monitoring system that should be thought of as the gateway to the performance information that can be retrieved from each inverter and its assigned PV modules. Again, the ECU uses the Zigbee protocol to communicate with each of the inverters. Please note that the ECU is not a standalone wireless device and requires an electronic bridge or direct Cat5 connection to communicate to a network router. The Energy Monitoring and Analysis, or EMA website, allows for 24/7 management and monitoring of the solar array via any web-enabled device, such as internet-connected computer, tablets, or smartphones. While the EMA functionality is covered in depth in another training session, a few basics are in order, so you have a better understanding of how the entire system is designed. First and foremost, as we've already stated, and you'll hear as a recurring theme throughout all of our training, the EMA is accessible to you and your customers only after you have registered and have an APsystems EMA installer account. This is a simplified typical three-phase system diagram. As described previously, the YC1000 can be assigned to 4 PV modules, typically described as channels 1, 2, 3, and 4. The ECU is plugged into a standard 120 volt outlet. A quick word on ECU placement. Because of the radio characteristics of the Zigbee communication protocol, the ECU needs to be within 200 to 300 feet and in line of sight depending on the site conditions of the closest inverter in the array. Contact APsystems technical support for additional recommendations if this placement is not possible. Here's a picture of the YC1000 and its associated cabling. It is important to note that the YC1000 uses an AC bus cable, sometimes called a trunk cable, for AC distribution. The AC bus cable can be ordered in 2 different configurations based on the distance between the terminal connection points, which is often determined by panel orientation, portrait, or landscape. It comes in both 2 meter and 4 meter spacing. Make sure to specify the spacing requirements and the number of inverter drops, which will be based on the layout of your modules in the array when placing your order for cabling. Besides the AC cabling, there are cable end caps, 1 per branch, T-sealing caps that are used to cover unused terminal connectors on the AC bus cable, Zigbee antennas for each of the inverters, and optional DC extension cables should you need them to reach between the modules and the inverters. The YC1000 is compatible with most 60 and 72 cell PV modules, with a voltage range of 16 volts to a maximum of 55 volts DC. It requires 22 volts DC and AC grid voltage to energize. Anything below that voltage level on the input side and the inverter will not power up. Note that 96 cell modules, up to 370 watts per module, can be used in 3-panel configurations. Check the module manufacturer's data sheets for voltage, current, and wattage specifications, and check in with APsystems technical support if there is a question concerning module compatibility. Verify the site's grid voltage prior to actually installing the system, making sure that it is either a 277 480 volt or 208 volt balanced 3-phase grid. Note that the 277 480 volt inverters operate within the 277 volt AC grid, and the 208 volt inverters operate on a 120 volt AC grid. And as a reminder, the YC1000 cannot be used in a delta or high leg system. All 3 phases need to be balanced for the YC1000 inverters to function properly. With all of the background information out of the way, it's time to start walking through the actual installation procedures. Step 1. Arrange and install the racking according to your layout plan. Step 2. Lay out the AC bus cable based on approximate inverter placement. Step 3. Attach the YC1000s to the racking system, remembering to account for panel orientation, portrait or landscape, and the fact that each inverter is going to be connected to multiple modules. Note, do not install the Zigbee antennas until after the inverters have been fully mounted to the racking system. Some things to note during the inverter installation process. Consider the weight of the inverter when selecting a rack solution. Each inverter weighs slightly more than 8 pounds, so mounting them on plastic-based racking systems may not be appropriate. Do not mount the inverters where they are exposed to direct sunlight. While the YC1000 will tolerate extreme heat conditions, we found that operating in direct sunlight will quickly push those limits. Allow a minimum of 3/4 of an inch clearance between the roof surface and the bottom of the inverter so that the inverter can dissipate the heat generated by the power conversion process. And again, do not exceed the maximum number of inverters in an AC branch circuit. Step 4. Place the modules onto the racking system and connect the AC cables from the inverters to the AC bus cable. Make sure that all unused terminal connectors on the AC bus cable are covered with T sealing caps, ensuring that they are weatherproofed. Step 5. Connect the DC cables on the module to the MC4 compatible DC receptacles on the inverter, being careful to make sure that the connectors are fully seated. The most efficient way to make the DC connections is to start the process with the receptacles nearest the antenna mounting threads, channel 4, and work your way to the opposite edge of the inverter. Note that the inverter's LED status light will flash red once, followed by 3 green flashes when DC power is first applied to the unit, indicating a successful DC connection. Step 6. Install the Zigbee antennas to each of the inverters. Step 7. Install a protective end cap at the end of each AC bus cable. Step 8. Install the AC branch circuit boxes. Install an appropriate junction box at a suitable location on the PV racking system, typically at the beginning of the branch of modules. Next, connect the open wire end of the AC bus cable into the junction box using an appropriate gland or strain relief fitting. Wire the connectors as follows. On the 277-480 inverters, it is L1 to black, L2 to red, L3 to orange, neutral to white, and ground or PE to green. The 208-volt connections are L1 to black, L2 to red, L3 to orange, neutral to white, and ground to green. Finally, connect the AC branch circuit box to the point where the system connects to the utility grid. Step 9. Pull the UID stickers from the inverters and transfer to the site map. As a convenience, you may want to place the UID stickers on your site map before installing the inverters. With the PV modules and inverters in place, and all connections thoroughly checked to make sure that they are secure, you're ready to energize the system. First, turn on the AC circuit breaker associated with each microinverter's AC branch. Next, turn on the main utility grid disconnect. Note, as a safety precaution against potential islanding, the system will not start producing power for a full 5 minutes after it detects the presence of the grid. Now that the system's energized, a few words about the inverter's LED indicator lights. The inverters have an LED indicator that is extremely useful in determining the system status beyond system startup. Assuming all is good with the system once it has been energized, the LED will flash green slowly every 10 seconds, meaning the inverter is producing power and communicating with the ECU as expected. If the LED is flashing green quickly, every 2 seconds, the inverter is producing power but not communicating with the ECU. This is a normal condition if you have not installed an ECU as part of the system design. Note that the green LED actually means that the inverter is sensing the grid within the set of AC parameters that have been programmed into the inverters. If, on the other hand, the ECU is part of the system design, and the inverter's LED is flashing green every 2 seconds, then you'll need to check the Zigbee communication from the inverter to the ECU, as well as verify that the inverter's UIDs have been correctly entered into the ECU. A flashing red LED is an indication that the inverter is not producing power. Check the AC and DC leads to make sure that they are securely connected. A solid red LED indicates the inverter has detected a ground fault. For the most part, Replacing the microinverter is as simple as reversing the installation process for removal and replicating it for reinstallation, with a few extra steps added to the procedure for your safety. You'll want to remove the inverter using the following steps. Step 1. De-energize the AC branch circuit by turning off the branch circuit breaker. With the branch circuit offline, cover the PV modules associated with the inverter to be removed with opaque covers, ensuring the panels are not producing DC power. Next, disconnect the AC connectors from the AC bus cable. Step 4. Disconnect the DC connectors from the PV modules associated with the inverter. And finally, physically remove the inverter from the rack. Follow the installation procedures we've gone over earlier in this presentation to install the replacement inverter, making sure to change the inverter UIDs in the ECU and EMA to reflect the changes that you've made. A few quick words about installing the ECU before finishing this training module. As mentioned earlier, the ECU collects and stores the performance data from each of the microinverters using the Zigbee protocol and sends it to the APsystems database via an internet connection so that the array can be monitored online. The ECU, while optional, is an essential component of the remote monitoring system that should be thought of as the gateway to the performance information that can be retrieved from each inverter and its assigned PV modules. It's also important to note that though the ECU communicates wirelessly with the microinverters, it does not connect wirelessly to the internet and requires an electronic bridge or direct Cat5 connection to communicate to a network router. Before jumping into the actual installation of the ECU, it's very important to understand how you're going to manage the inverter UIDs prior to the installation and registration process. To save installation time and money, consider configuring the ECU before you head to the job site. The ECU can be easily pre-configured and registered in advance, ensuring simple plug and power operation on site as the customer's system is energized. We'll cover detailed ECU programming instructions, including this time-saving pre-configuration and registration process, in another training module that is focused entirely on the ECU setup and functionality. When installing the ECU, it's always best to establish Zigbee communication first, and then internet connectivity. As stated earlier in this session, the ECU is plugged into a standard 120-volt outlet, and you want to get it installed as close as possible to the array to eliminate as many communication problems as possible. Because of the radio characteristics of the Zigbee communication protocol, the ECU needs to be within 200 to 300 feet, depending on the site conditions of the closest inverter in the array. Contact APsystems technical support for additional recommendations if this placement isn't possible. With a stable Zigbee communication established between the inverters and the ECU, connect the ECU to the internet using one of the following three options. Option 1, which is the most straightforward approach, although not always convenient because of the ECU placement, is to use a direct Cat5 Ethernet cable connection between the ECU and broadband network router. Option 2 is to use a Wi-Fi range extender to wirelessly connect the ECU to a wireless broadband network router. This option requires you to connect the range extender to the ECU using a Cat5 Ethernet cable, which in turn is joined to the LAN that has access to the internet. Option 3 utilizes a power line adapter to make the ECU to router connection via the power lines in the structure. The typical power line adapter is a two-part piece of technology, send and receive units. The send unit is connected to the ECU, and the receive unit is connected to the broadband router. This concludes the YC1000 inverter training. Should you have any questions, please feel free to contact APsystems Technical Services at support@apsystems.com. Technical Services will send an email to the contact name you have provided once all of the required training sessions have been successfully completed and your installer account is ready to be set up.